This is Beethoven's Fifth Physics by Nadja Williams, Sidney Boyd, and Ellie Grasso. Our objective for this experiment was to find and record the changes in frequency when a mass is added to the highest and lowest pitched strings on a guitar. We predicted that the added mass would moderately decrease the frequencies of the strings because the mass increases the period, which has the opposite effect on the frequency.
Here is our video. We measured out 0.9 grams of Play-Doh and placed them on the highest and lowest pitch strings, which had the scientific pitch notation of E4 and E2. We then used a lab quest to obtain the difference in frequencies.
This is where we place the Play-Doh on the highest and lowest pitch strings. Our experiment was inspired by a German physicist named Ernst Chladni, who is well known for his research on vibrating plates. He was inspired by a scientist named Robert Hooke, who also observed the nodal patterns associated with vibrating glass plates. He did this through running a violin bow along the edge of a plate, which was covered in flour, in order to see the nodal patterns emerge.
Initially, we found the frequency of E4, the highest string, to be 328.12 Hz, and we found the lowest string, E2, to be 250.0 Hz. But after the Play-Doh was placed on the string, E4 then changed to 46.88 Hz with a difference of 278.24 Hz from the initial, and E2 then changed to 62.50 Hz with a difference of 187.50 Hz from the original.
The first two graphs showed the frequency, and the last two graphs showed the sound pressure of the strings in 1/16 of a second.
From our observations of the frequency of the waves, we were able to tell that increased mass does in fact decrease frequency. This is due to the fact that the increased mass causes an increase in the period, which means that the wave takes longer until it ends, which creates a lower frequency. This proves our hypothesis correct.